Hi guys, Mike here. So a few people have asked me about stress analysis or finite element analysis, which is known as FEA. So what I thought I would do is quickly show you how to set up a static stress analysis in Inventor. So up at the top we have environment. So this is also where you find things like Inventor Studio and 3D Print, which are covered in a couple of my other videos. So we're going to hit stress analysis. And the good thing about Inventor is pretty much every workspace you're in, you kind of follow this from left to right along the top. So the first thing we're going to do is create a study. Now in here what we can actually do is set up a single point or a parametric dimension. So I'll probably do another video to cover parametric dimension. You then have the choice of a static analysis or the modal analysis. And if you're running 2017 R2, then you'll also have shape generator. So we're going to keep it with a static analysis, and I'm going to press OK. So now you can see it's created a study, and again we just carry on along the toolbar along the top. So the first thing you would normally do is assign a material. I've already actually set this in the model space, but if you wanted to override it, then you can in here. Then what we're going to do is set up a constraint. So you can set up these three types: a fixed constraint, a pin constraint, or a frictionless. So if I just go ahead and show you a fixed, so you can select any face. So I'm going to select this in a circumferential face here, but you can select this face or any of them. So just hit that one there and just press OK. And now what you can see is we now have a constraint in our browser on the left here underneath the study. So you got their fixed constraint. And now you've got in loads, you've got a bunch of different types. We've got force, pressure, moments. But I'm just going to go ahead and add a force. So you go over here, I'm going to select this face. You can select edges. I'm just going to pick on this top face and let's give it a force of say 600 newtons. And again, you can flip the direction here. You can select another line, for example, to give it a direction. But we don't want to do any of that, so we'll just keep it back how it was. There we go. And change it to 600 rather than 60. So now you can see under loads we now have a force, and again you can edit all of this here. So I can edit the force load, I can edit the fixed constraint, all within here. Now we've got a constraint and a load. That's pretty much it. We can now go ahead and simulate. So what I'm going to do is I'm going to show you that. So I'm going to run the study, off it goes. And now you can see we've already got some results. So here's the von Mises stress in here. You can see, no surprise, this is where the most stress is. And then what we can do is cycle through all of these down here and view the various different results. Now what we found is because there's the highest amount of stress here, what you can also do is if I go back into the mesh view, we can actually say, well, I prefer it if this was actually a more accurate mesh. So this button just here is actually the local mesh control, and I can select edges, but what I'm going to do is I'm going to select that face just there, and then what I can do is say, actually I want the element size there to be, let's say, 1.5. And then what you can see here is the results and the mesh out of date. So we've got this little lightning bolt here. So if I right click on the mesh here and update mesh, it will go away, it will update the mesh. You can see now we have much more elements in there. And then if I hit simulate again and rerun that study, you'll see now that we've got a higher mesh, so the results should be more accurate. And of course, I will admit I don't know what all of these different ones mean for this part. So what I would do is I would go up here. There's one thing you can actually animate this. So you can just hit play and it will zoom there. You can see it will animate and show you the stresses as this part deforms. But what I would normally do, if I just stop that, you can also record that, send out. I would hit the report. You can now put in here things like the report title, the author's name, etc. And then you can choose the output. So I'm just going to go OK, and you can see what this will look like. It goes away and gets a load of nice screen grabs for us. So you can now see this is our stress analysis report. And again, like I said, I'm not an expert, so I would produce this report and give it to somebody that is. But you can see here it gives them all of the details that are basically contained within our CAD model. So the start here is just showing them exactly what we did. So it's showing them the constraints, and then it's showing them the force, and then obviously the results. But you can see now that it's very simple to produce an FEA study. Obviously understanding it is very different. But hopefully that gives you an idea of how to quickly create an FEA study and get some meaningful results.